Okay, so guys, in this video we have to find the implicit differentiation with higher derivatives. So we have studied the implicit differentiation. Now we are going to apply the rules of higher differentiation or the successive differentiation while solving for the implicit differentiation of any function or any equation given to us. So we are given equation x square plus y square is equal to a square. As usual, we are not actually given the equation properly. We have to find y2. So what is y2? It is actually d square y divided by dx square, i.e. we have to take the derivative 2 times. Okay, so we will have to apply the differentials 2 times. First of all, let's just apply the differential first time on all of these terms. Whenever we are doing the implicit differentiation, we have to apply the derivative with respect to x if x is given in the equation. If it is not given, then we will have to see what are the derivatives and what are the situations according to which we will take the derivative. But in most of the cases, you will be given x and y, and according to which you have to take the derivative with respect to x. So the derivative of x square would be 2x. Now the derivative of the angle, what is the angle? It is this thing right over here. Plus the derivative of y square would be power separated, the function as it is, power minus 1, 2 minus 1 is actually 1, multiplied by the derivative of the function. What is the function? It is y, d by dx y. The derivative of a square would be 0 because a is a constant. This will be cancelled, and 2x plus 2y dy by dx is equal to 0. Now this is the thing which we want to separate. Okay, so let's just subtract 2x on both sides. So we have 2y dy by dx is equal to negative 2x, and then we want dy by dx, right? So we will divide 2y on both sides of the equation. So we are left with dy by dx is equal to negative 2x divided by 2y, and of course you can cancel these. So we are left with negative x divided by y. So this is actually y1, the first derivative. Now we will find the second derivative. So I have just applied the differential second time on this equation right over here, and I've separated the negative signs. Because negative sign is actually a constant, the derivative won't have any effect on it. It will go as it is along with the equation. So the negative sign as it is. Then this function is actually fx, and this is my gx. Okay, so we can use the dividing principle of derivatives. So we have fx and gx. Second function as it is, negative sign will be separated, and let's just separate it by a bracket. Second function as it is, derivative of the first function, that is x, minus the first function as it is, derivative of the second function. What is the second function? It is y, divided by the square of the second function, y square. Negative y, these will be cancelled, so we're left with 1 minus x dy by dx divided by y square. Okay, so let's just multiply this negative sign. So we have negative y, minus gives us positive, so minus x dy by dx divided by y square. So we have d square y and dx square over here, and this is dy by dx. Remember, we just found the value of dy by dx. It was negative x divided by y. So let's just put it over here. So it will be negative y minus plus minus x multiply x is x square divided by y square. So we can take the LCM. So y, and this is the actual denominator. So y, when taken as LCM, will be multiplied by this y right over here. So we have negative y square, negative x square will be as it is, because it is actually, the y is actually present under the x square. It will be divided, and we are left with 1, so x square, and the y square is the actual denominator. So this y will be multiplied by this denominator right over here, and we are left with negative y square, negative x square divided by y square multiplied by y gives us y cube. Okay, so it is basically something like x divided by a divided by m. So we can move this a towards the actual denominator. Okay, so we can actually move it downwards. So we will be left with x divided by a dot m. So this is my a and this is my m. So I literally moved a towards m.